Okay, so here we have another example, clean slate here. I'm going to set up my formula for the vertex, negative b over 2a, and f of negative b over 2a. Then I'm going to identify my a, b, and c. So my a is negative 1, my b is 2, and my c is 4. In this case, I see that a is less than 0 or negative, so my parabola is obviously going to be going downwards. All right, so let's find out what the vertex is by substituting the values of these constants into the variables. So that's negative 2 over 2 times negative 1, which is, the 2's cancel. It's actually positive 1 is my solution, right? That's my x, also known as the axis of symmetry. Axis of symmetry. All right, so I have my first point in my coordinate system, and now I'm going to substitute it in my function f of 1, which is negative 1 squared plus 2 times 1 plus 4, which is negative 1 plus 2 plus 4, which is 5. So my vertex says that when x is 1, y is 5. So that's my vertex. And no, I'm sorry, when x is 1. Oh, apologies. I stayed on the axis. I treated it as an intercept. When x is 1, y is 5. So it's right here. So I know my graph is going to be going downwards, but I need to find values to plot it properly. So I'm going to do the pull out the sky, f of x or y. So I'll pick just randomly when x is 0. What happens when I plug in 0 in this function? I get 4. I'll say when x is 1, what happens when we pull in? We get 5. That's already a point there. And then, you know what? I'm just going to continue to use small numbers. I'm going to say what happens when x is negative 1? What's y? So let's do negative 1 into negative 1 squared plus 2 into negative 1 plus 4. So that is still a negative 1. That's a minus 2. That's a plus 4. So it's minus 3 plus 4, which is 1. All right, so let's see what we have going on, what we're working with here. X is 0, y is 4. X is negative 1, y is 1. So it looks like so far we have some points going down here. And since it's symmetrical, we got to find some points that are going down here. So I'm just going to continue to look for some. I'm looking for something symmetrical. What happens when x is 1, y is 5? We have that. What happens when x is, if we have negative 1 here, let's try 2. Let's try what happens when x is 2. So when x is 2, we have negative 4 plus 4 plus 4. We have it's 4. So when x is 2, y is 4. So we have another point right here. So we could pretty much see where the graph is going. I won't stress it too much, especially on the exam. I'll take this. And here we have our graph. Let's see if we're correct with number 3. Da-da-da! Check. All right, moving on.